everyone, and welcome to the Data Science webinar series. Today's topic is overcoming model failure. Dr. J. Kyle Roberts will be showcasing common reasons for model failure and kind of dig into deeper and discuss tips and techniques for overcoming each of these problems. A few notes before we get started. This webinar is being recorded, and the recording will be emailed to you in the next few days. We will also be opening up the webinar for questions at the end, but go ahead and feel free to submit any of your questions in the Q&A panel found at the bottom right of your Zoom panel, kind of as we go along. A few introductions. My name is Rachel Mason. I'm the marketing specialist here at Teknion Data Solutions, helping out with this series, and Teknion is happy to be hosting the data science series along with 3 other series. So be sure to go check out upcoming exciting webinars that we have both here, and then we have some in data pipeline, data strategy, as well as visual analytics. And at this time, I'm gonna turn it over to Teknion's data scientist, Dr. J. Kyle Roberts.
Well, hello, everybody. Thanks for joining us. Excited to be able to bring another session and series on this data science webinar series, and this one is probably one of the most frustrating ones for me, and also too, it's a little bit like me throwing a dart against a wall and then drawing a target afterwards, because I'm going to talk about the reasons that I experience model failure, but that may not be some of the reasons you do. So here's how I'd like to do this. We're going to probably spend about 30 or 40 minutes, and I'm going to show you some things, and then and then there will be opportunities for you to kind of ask questions at the end, or maybe talk through some of the reasons why you're having some difficulty with some of your models, let's get some feedback on that. But really, just the first part of this is talking about, look, here are the ones I see really frequently, and maybe a couple tips and tricks to getting around those things. And so I know there's a frustration level, especially when you have a tool like Alteryx that is actually leveraging R or Python, which is another model building tool. And sometimes you get some things that are lost in translation, but we will definitely work through that here. So just a second about myself, and so I know many of y'all, and but just wanted to share this, that previously I was a professor at Southern Methodist University, and then before that Baylor College of Medicine, doing research, and then way back at University of North Texas for a short stint. But really my background is in R. I do a lot with, before joining Teknion about 2 years ago, actually, goodness, it's almost 2.5 years. Before joining Teknion, I spent a lot of time in R. That was what I did 100% of my work in, and actually have written in conjunction with one of my students, the Y-Hat package inside of R. And then do a lot with multi-level modeling, and even co-authored the Handbook of Advanced Multi-Level Analysis. And so for those of you that are having trouble sleeping at night, be sure to pick up a copy of it on Amazon, because it is dense, and it's not an exciting read, but it is a good read. It is if you are into multi-level analytics. Anyway, okay, so let's talk about what we're looking at when we talk about model failures. So I love this because I was playing around the other day and just looking at Google on overcoming failure just as a joke, and actually I thought this was pretty good advice. This is, if you were to type in overcoming model failure, the first thing that would come up in Google is this website called Fast Company that was 4 steps to overcoming failure and using it to your advantage. And I love their 4 steps where accept that failure is part of the process. Boy, that's the first one and the most important one. This has, oddly enough, this article has nothing to do with model failure or data science or anything like that, but it does have a lot to do with kind of how do you overcome failure in your personal life. Oh my goodness, if I had, $1 for every model that I've had that fails, I'd be a wealthy person right now. It's my models fail more than they actually work, but that is part of the process, is getting to that final model that you're like, okay, I think this thing works, I think we're good. but I have lots of failures. The second thing is let out your frustration. You're going to see some things, especially when we're inside of Alteryx, that you're like, what the heck does that mean? It's okay. Get your punching bag, hang it down from the ceiling, get ready to punch it. And then but the funny thing is this third one, I think, is the most true when they say, be brutally honest. And they're really saying that with yourself about failure. But in this case, the reason that really holds true with modeling data is because some of the times we're going to see that the reason that the data, that model fails is because you didn't do a good job collecting your data. Or you don't have enough content knowledge about what's going on with your modeling. And so I'm going to show examples of both of those, where you didn't do a good job connecting your data, or you weren't, you don't have enough kind of maybe pedagogical content knowledge to be able to make good decisions about this. Now, the reason that I put that in there and left this in there for be brutally honest is there's more than a few times that I am with a client and they literally hand me some data and say, would you analyze it? That is the worst of all possible scenarios, meaning when someone just says, hey, here's our data, would you analyze it for us? Because the philosopher's hat does have a place when you're doing statistical analysis, meaning that I don't just magically plug in all the data into a machine and then let the machine say, all right, here's the answer, or here's what you should have as a result. Partly because, especially with really large data sets, we have what we can measure are spurious effects, meaning that the algorithm may detect that there's some sort of effect, and maybe it's small, but because you have millions of people in your data set, it's detecting even really small effects. And now you have to explain something that probably actually isn't there in the data, but just happened to appear as an anomaly, or isn't there in the population, but happened to appear as an anomaly inside your data set, and that you're saying that there's some connection that there actually isn't. And then the last thing is fail forward, meaning that as you make your failures and as models start to fail, again, you don't want to just keep smashing the machine, hoping to get a model that does work. The hardest thing about this is figuring out why your model failed, and why it's not producing the type of results that you want, and then failing forward from there. Okay, what can I glean from that to move forward? Okay. So I typically think of model failure in two types or two areas. One is they generally fails because of bad code, meaning that I've written bad code in there. But the second failure is because data has changed. And now here's the important part about that second point. When you start building models and you change behavior, hopefully it's for the good. And so the behavior that you'll change will be more along the lines of, hey, let's start using the data that we have to make better decisions. And ergo, we're going to have different data on the back end. Well, if we keep using the same model based on our old suppositions, then it would stand to reason that model won't work in kind of a new area. So imagine if all of the banking and investing models that are developed right now during COVID, that are developed right now, are based on some, people working from home a lot more people out of jobs. If we base all of our investing models on that, then what happens when when we move out of this period and people do start traveling more, and or we have an airline investment scenario, or even when we have an airline, we're trying to model, how many airplanes we need to have in the air for the next, the next month. And in a COVID period, that model needs to look different than in a non-COVID. And so recognizing when your data has changed, when your model doesn't look good anymore, and then looking at those competing models is actually a pretty good idea for how do we, one of the reasons that we do have model failures, because one model doesn't work good forever. It's always going to change. Okay. All right. So we need to talk for just a second about this true score theory. And this This is an older slide for those of you that have sat down on some of these data science webinars before, but we do need to talk about this, and let me see if I could show you why. So the idea behind true score theory is just saying that anyone's observed score, or any observed score at all, equals true score plus error. Meaning that if let's say we're taking a psychological assessment and I'm trying to discover how outgoing you are. Okay, well then I may give you, let's say 35, 36 items, something like that, or if I'm doing the MMPI, I'm actually going to give you 512 items. I mean, a whole bunch of items to try to determine how outgoing you are. And so I'm using those items as a proxy for an actual behavior. And so those are the observed things. I observe you with 36 different items, and then I'm trying to use that as a proxy for how outgoing you are. And I recognize that my 36 items don't connect with you on every level of outgoingness, whatever that is called. Okay, and so I'm trying to measure whatever your true score is plus your error in there, but I don't know which part of it is associated with your actual score and which part of it is associated with your error. Now, why do I bring this up? Because a lot of times people, when they're collecting data and then they push that data out into a model, they assume that whatever I observe is your actual value. So they say if they get some score for outgoingness from that Minnesota multiphasic personality inventory, then they're assuming whatever I observed, that is your actual outgoingness number. But the truth is there's a lot of error in there. And we often like to think that, hey, their true score, is really 90% of what I observe, and there's only 10% error. The error is pretty small. But in actuality, it usually looks more like this, that the observations that I'm making about what's really going on with you and how outgoing you are is really, there's a lot of error inside there. Now, the only time that we don't need to use this is if we're doing something like physics, where we'd say, okay, exact amount in and exact amount out, those two sides of the equation equal each other, that observed and true. I mean, as long as we're watching everything well in a physics type setting. Okay. Now, again, we're bringing this up because when we do things like forecasting, or when we do things like, okay, getting models to say, what's the market going to do for the next 10 days or 20 days or 30 days or something like that, what we're doing is we're saying, based on past trends and these other variables that I'm observing, can we predict what's going to happen in the market in the future? Well, sort of. I mean, it's not perfect prediction. And for those of you who have ever done this type of modeling, we need to recognize, look, there's a huge source of error that we're seeing in here. And we're trying to minimize this. I mean, the whole goal of statistical modeling is this orange part. We're trying to minimize that orange part. That's what we're going for. And that's what we're trying to do, is minimize that amount of error. Okay. All right. So having said that, many times our models are going to fail because we just haven't done a good job of observing what is actually out there, or including variables in our analysis that actually really do model what is in the real world. And so that's one. The problem is golly, this is really hard to know. I mean, maybe there are some things, I mean, I love the idea of there are these exogenous variables, or these variables are kind of outside of our model that we don't know if we've measured them or not. So it's the kind of the whole philosophers, we're looking for a black cat in a dark alley on a moonless night, and that cat may or may not be there, right? And so we don't know which variables we haven't included in our model that could be explaining what's going on there. And so sometimes you just don't know what you don't know. But as we know more, as we start to learn more about our fields, we'll get better at, okay, these are the variables that seem to correspond with my outcome, and we'll have models that will tend to explain things better and not fail. But also that recognition that, under these types of conditions, this model works well, and under these types of conditions, this model works well. That's why I love reading about not day trading, but computerized trading, who are doing high frequency trading, so HFT, that are making 3, 4, 5,000 trades a day, really high frequency trades, that they're constantly looking at the market and going, okay, we're doing these high frequency trades, but when the market shifts in certain directions, don't use this model, use this model, because this one works in that new scenario. So again, we're always wanting to watch out for that. When does our model work and when does it not work? Okay. All right. So here's some examples of model failure in Alteryx we're specifically going to look at. So the first is we're going to look at model failure due to something called target leakage, and I'll get back to that. The second is we're going to look at model failure due to what's called constants in our data set. And so we'll look at why do we have model failure there. And then we're going to do some model failure due to missing values. Because we'll see that models just won't run with missing values inside of Alteryx. And then we will look at there will be the kind of model failure due to changes in data, meaning that's that last thing that we're talking about. So what I'd like to do next is let me open up Alteryx and we'll go start sharing that with you. Let me pull that back up real quick. And then as Alteryx is coming up, we're going to talk through a few of these. Give it just a second. Oh, my computer is enjoying being exceptionally slow today. Sorry about that. All right, here we go. Okay. So let's first talk about some of these model failures. Now, this first one I want to talk about is target leakage. So in this case, I'm going to use this data set that I have. It's called linear data that I've created just for doing some fun predictive stuff. And this is a synthetic data set that I created just kind of prove a few points. Okay. So in this one, we're going to try to predict how much someone is going to spend in our store based on whether or not they're a rewards member, their combined income, and where really we multiply that by 1,000 to get the actual income. All right, number of credit cards, and then their age. Okay, so we're trying to predict that. I'm going to add a variable into this model, and here's what the variable is going to be. I'm going to take current spend, and I'm going to multiply that by 4. All we're going to do is we do current spend and multiply it by 4. Actually, I'm going to take that variable. Well, I'm going to leave that variable in there also. We're going to do something with state here in just a little bit. Okay. So in this, let's run our multiple regression. But I've got this variable in there, spend 3, which is just my outcome variable, that current spend. It's just that multiplied by 4. That's all it is. Okay. So let's run this model and let's watch what happens. All right, there is my error. Already seeing it there. Okay, let me scroll up a little bit to talk about, and let's look at all our errors. Okay, we've got these really cryptic errors in here. And really what this is Alteryx is booting up R, and it's telling R, or R is telling back, hey, here are the errors I had when we tried to run this. So we have this error in ANOVA.lm, okay? This appears, and I'm going to tell you why they appear, but again, it's one of those things that's hard to know, but you kind of have to know R to know some of this. Error in ANOVA.lm, what happens there is it's trying to run some fit statistics, and it winds up having to divide by 0, and that's not good. We always hate it when we divide by 0. What's the saying? So it's saying execution halted, so that means it got to that tool, it had to fail. There's another tool in here that it's looking for a value called fit stats that's not contained in there. And so error, R is going to error out again too when it's trying to read that back in. So it's looking for an output from that regression, and it's not seeing an output. Now here is the reason why. Let's just pull out this Pearson correlation. Okay, I'm going to connect that. There we go. And I tell you what, for right now, I'm just going to delete this part so that it'll run a little bit faster. Okay. So if we run a Pearson correlation among all of our variables, and for those of you that know stats, you'll know what the problem is going to be here. Okay. Current spend, or actually I misspelled it, current net spend, but current spend is perfectly correlated with spend 3, perfectly correlated. Okay. And so this is what we call target leakage. And so we have a variable that's really just a rescaling of another variable, and they perfectly are correlated with each other. When that gets included in the model, then as a predictor, then our model is always going to fail. Now, why do I bring this up? Because it happens all the time that you'll have a model and then you get this really cryptic, weird R code at the end that's telling you, all right, man, something really strange is going on. But it really, there's not enough information coming out of the Alteryx output in order to be able to help you on that. Okay, so this does happen when it's target leakage, meaning that you have a variable that's either perfectly correlated with the dependent variable or almost perfectly correlated. So that always is a problem. So a lot of times if we are doing regression, we want to check with this. Okay, this also happens that, let's suppose you're doing like a decision tree and you have a categorical variable that's like what school, this has happened before. You're trying to predict, maybe the classification of the schools, and they're all from different regions. And so you include as a predictor the region, and each school is perfectly nested within its own unique region. And so you might have, you might have a perfect prediction there. And so that's, again, another problem that could exist in your data set, is that when you're doing categorical stuff, you have another categorical variable that basically sits right on top of your outcome variable. So we would see errors like that. So again, that's kind of we have to look at what variable, but again, as we saw, Alteryx doesn't tell you, and R won't tell you this is the variable that's perfectly correlated. So you always need to check that for target leakage. Okay. Now, another problem that we could potentially have, and let me pull my linear regression tool back in here. This time we'll also do current spend. And let's suppose we are doing, instead of, I'm going to take this spend3 variable out of there, we're including a variable called state. Now, here's the problem with state, is that, so let me pull in a browse tool on right here. I tell you what, let me delete that just so we can run this and look at what's going on. For state, if I go down here, there we go. There's my variable state, and it's got state number 7. And if you look at here, there are 217 rows in my data set, and there's only one option for state, and all 217 people have that same value of state. So it's all from the same state. If I include, let's watch what happens if I include that variable in my model. Now, this one isn't so much model failure as it is, we're going to just see some weird stuff. So let's add current spend, put all those in there. Let's take spend 3 out. We're going to rerun this, and then we're going to see some really weird stuff in our data, or in our output. So we'll pull it up. Give it just a second. Okay. So first, if we're looking at just the output from R, we'll see that everything next to state, it says NA. Okay. It's just, we got an NA in there. And what that means is that for every person in the dependent variable, they all have the same value for state. So you'll see this sometimes in your models. You're like, what in the world? Why is that in there? And so and here's the reason I bring this up, is that sometimes you may do a multiple regression, but then you do multiple different regression models for different subsets of your data. Well, state may be a good predictor of current spend when you're including national data, but when you aggregate it by state and then you forget to put that in there, all of a sudden that variable that was statistically significant or practically significant for you, now all of a sudden is not statistically significant anymore, and you got these NAs and you can't figure out why. Well, that's because everybody has the same score on that. And then if we're looking at the improved Alteryx output on this, you can see, oh, give it just a second. You can see some of the things that are going on here. Okay, so again, age that's completely blank. All right, and then if we look at diagnostics, those should still be okay. They shouldn't be affected at all, because really what it's doing is it's dropping that variable out of the analysis. Okay, so that also happens too when you have constants in your model, which by constant, I mean, all I'm doing here is I'm saying, all right, let's spin the state variable. Everybody has a score of 7. Okay, so we have that. So, all right, there's 2 ways that we may see model failure. Okay, now, if we're thinking back to what I was showing you from the PowerPoint is the first was, model failure due to target leakage. The second was model failure due to constants. But this is really the most common one, is model failure due to missing data. And so I want to show you a few of the a few options on this, or what can happen, okay? And what failure looks like if our data is just, we have blanks in there. So I created a data set that I'm just predicting this DV, that's the dependent variable. I'm predicting the numbers 1 through 15, and so they have scores on IV 1 and then IV 2, and you see we're missing some values in here. They're just kind of missing. They don't actually appear as null, but they're missing. So when I run this analysis, we're going to get this kind of weird error that's going to come out from this linear regression. Okay, and here's what it says. The vectors passed to Alteryx predictive R squared were of unequal length, okay? And so what's happening is, because we have missing data in there, it's really looking at this, it's looking at this and saying, hey, I've got one piece of missing on this IV1, I've got 1, 2, 3 pieces of missing of an IV2, and I'm expecting 15 values in here for IV1, because that's what we have in the dependent variable. And I'm expecting 15 values for IV2. Okay, that's what I'm expecting. And I didn't see that in the data set. And so, ergo, I'm getting this error message that's telling me, all right, those vectors are of unequal length. Okay, so they're not the same. All right. Now, so that's just when the data is blank. And then when it's null, and the reason I want to show you this is we're going to get slightly different. So I took that same data set where there was, instead of, so I put zeros in there, and then I'm changing those zeros to a null value. So I'm saying if in IV1 or in IV2, if there's a 0, then put a null in there, else just return that same value. So now if we run this, we'll see that we're going to get another error message. Okay, so, and again, we get this vectors were unequal length. And then we also get this one, this kind of a warning that's saying, hey, you really don't have enough rows to generate a model successfully. Okay, that's coming out of linear regression. Now that is an Alteryx note there. It's just saying, look, you've got really small data set. It's just a warning. It's just kind of a fix for you saying, hey, you're trying to run a regression with 3 variables, or 1 outcome variable, 2 predictive variables, and only 15 rows of data. Probably a bad idea. Okay, all right. So that's the same type of error that you will get. And this is the vectors were passed of an unequal length. That is, again, that's a problem there that we're seeing with the null and with the zeros, okay? All right, and with the blanks. All right, so let's look at one more. What do we do? So let's suppose, though, that we have this data set coming in, here's the nulls, okay? That's the nulls coming through. And what if we want to, what if we do actually want to do something with that? So we can do different types of imputation, and the most common is what we call mean imputation. Okay. Generally, what we have to do is we have to clean our data, and any row that has a piece of missing data in it, we have to delete it or get it out of there. Okay. And so, so we generally would have to do some work on that to get that data clean coming in. In this case, we can do something called mean imputation. There's something also called hot deck imputation, where we actually do kind of a series of regressions in order to predict that. We can impute the median value. We can do whatever we want. But what I'm doing here is I'm just saying, all right, what I want you to do is take this IV2 variable, okay? And in that, let's compute the average of it. So I pulled in a summarize tool. Let's compute the average of that. And now what we're going to do is we're going to append that onto the end of our data set. So let me run this real quick, and I'll kind of show you what this looks like. So the data coming through here, we've got these nulls in both IV1 and IV2, okay? And then, so what we've done with this summarize tool is said, just compute the mean or the average of IV2. And now we're going to append it onto the data set. So there we are, we've appended it. And now with the formula tool, I can say, hey, in IV2, if it's missing, or if is null IV2, meaning if there's a missing value in there, then just put the average in there. Otherwise, give me the original value and then indif. So you can see now IV2 now has no missing values in there. And yeah, that works pretty good. Okay, so that's a way. And if I wanted to, what I could actually do is, if we were changing that, and I didn't want the average, I can do, let's see, where is it? Median is actually also a lot of people. So there's quite a bit of literature around which one is best to do, mean imputation or median imputation. And so that's going to change that variable though to not average, but no, it changes it to median. Okay. And now if we run that, instead of putting in the mean, it will actually put in the median value there, okay, for IV2. All right. Okay, so that's kind of how we would handle missing data. I want to show you one more type of model failure, and I'm going to use this data set to do it, this linear data set. And I do want to show you what this looks like. So let's suppose, so what happens in a model failure when the model is just no good at all, like none at all. Okay, so let's do a decision tree analysis where what we're going to try to do is we are going to try to predict the number of credit cards based on all this other information. We're going to try to predict how many credit cards a person has based on their current spend, based on their current spend, whether or not the rewards member are combined income or their age. Okay? Well, the reason I want to show you this is I want to show you what happens in a model where you're trying to predict something and your model is just no good at all. Like you're getting absolutely no results on it. Now, a decision tree, you remember, the first thing it tries to do is find variables that are good variables to be able to predict the category of your outcome variable. And so in this, we do get a note that says the target variable is numeric, however, it has 4 few unique values. And so it does look at that and say, so you might be inclined to say, hey, the problem that we're facing here is we need to change the outcome variable from numeric into a string. And so I can go ahead and do that just to show you that's not the problem. So number of credit cards, we're going to change that into a string. We'll rerun it, and we're still going to get errors. Okay. There we go. Okay, but the error is different. So this error has the minimum cross-validation error occurs for a CP value where there are no splits. This one is actually helpful because what it's telling us is that when we tried to run the decision tree, none of the variables were good enough to actually generate any splits. Now, if we hadn't done it this way, let me, hang on, there we go. Let's delete, oops, there we go. We'll delete and connect around here. And so we'll run both of them just so we can look at the differences between the two errors. Okay. That one is the minimum, the cross-validation is not working, right? Meaning that you don't have any good variables for predicting the outcome, okay? And in the second one, because we kept it as a numeric value, we've got all this weird code in here, okay? There's an error in data frame, this execution is halted, r.exe code indicated an error and subscript out of bounds. Now, again, all these things are absolutely meaningless because it's really just R is sending over some errors and Alteryx is trying to interpret those, and it's having trouble doing that. But this is an example of when we would have a model that fails because we just don't have any good predictors. I mean, there are no good predictors at all. That's why the model is failing. It's not because there's something inherently wrong with missing this in our data or something like that. But there's actually a problem with how we're modeling this data set. Okay, so this is a lot of information, but I do want to I want to go back to thinking about some of the things that are, that we saw from that we saw from when we were talking previously about like what are we going to do inside of Alteryx, that we are going to have these model failures due to target leakage. We've seen that due to constants. We've seen that, and model failure due to missing values. We've seen that, and then the other model failure for when you don't have any good variables in your model. Now this last one is the hardest one to talk about, because in order to monitor model failure due to changes in data, we typically want to think about that as we're constantly having competing models. And so we're testing other models, and we want to be able to monitor when is this model not a good model anymore. And so it depends on, and here's the reason why I say it's hard on this one. This is when you may want a data scientist to kind of partner with you on a project like that, because you're doing a continuous monitoring of, okay, we're constantly feeding it new data. How well are we doing in real time with, predicting that data and then seeing the outcome later on? Setting up series of things like in Alteryx, we might want to use a product called Promote in order to, look at how is that model going to react in time. And when we're constantly sending it data, can we monitor the model health? Now we may want to do some things to promote, to expand Promote to help on that endeavor. But we definitely want to make some effort on that front of as we're constantly, how do we know the model is doing better or the model is doing worse, and monitoring those things. And again, this is probably when you go, if you're not a data scientist, you go, okay, hey, this is when I want to engage with a data scientist I've got a model I like, how do we push it out into production and continually monitor it? It's as unique as there are many models, because I can't tell you something like, hey, when your R-squared drops below 0.5, then you probably need a new model. Because if we're doing cancer research, we really, an R-squared of 0.5 is going to be fabulous. It's going to be outstanding. But being able to monitor those things of when, hey, this model's no good anymore, it takes a considerable amount of effort. It is very, very context specific in the types of things that you can do. Okay, so that last one is kind of the harder one. All right. So what I want to do, that's all of the material I've prepared for right now. But we have the chat open. And so what I'd like to do is just open it up for if you have questions specifically about models you've run or things that you've done, and you want to ask questions about that. This is the time to do that. And again, I purposely left some time here at the end where we can talk about, all right, specifically my models are failing, or the model failure looks like this. And so you want to add those questions, or if you want to ask those questions, sorry. And Rachel, this would be where I'm assuming typing them in is the best way to go. Although if you wanted to enable participants to be able to ask some questions, we could certainly, outside of just typing it in and enable their microphones, we could do that too. That's up to you, Rachel.
Yep, we definitely have the option to take you off mute if that's easier, but definitely.
Okay, and is there a raise hand option there that you can monitor? Okay, all right. So if you do have questions, I'll give it just a few minutes if you're working on those. Okay, well, I guess it doesn't look like any, but really those first ones are the ones I wanted to, or did you have one, Rachel, or? Well, looks like
we have one in the Q&A.
So that's a great question. I built this. So the question was, you built this on trial and error. Is that being documented anywhere? That's a great question. It is on, so I will say this, the Alteryx community is really good about, you find these errors and holy cow, what does this mean? And then the Alteryx community is really good about getting at why that error appears there. And so I would say it's a bit on trial and error, but it's also really a lot of it is heavy on I really understand R. And so that's how I look at some of those things and I go, okay, I know why R is giving that command back to Alteryx, and Alteryx is interpreting it this way. There's not a lot of documentation on this other than using the Alteryx the community, using the Alteryx community and posing a question up there. And lots of times it's just a screenshot of, hey, could someone help me? I get this error when I run a forest model, or when I get this error when I run a neural network or something like that, and pulling those things up. It is sometimes hard to decipher. And so sometimes, I mean, someone will put one up and I'll look at it and go, it's usually this, but every once in a while it's something really weird. And so a lot of times there's asking for either, hey, we can do a screen share, or can you create a, anonymized version of that? I think the frustration often comes though, because there are some times that, like, let's say you're working with banking data and you get a model failure, and man, you can't share that with anybody because of PII. But then trying to get into some of those questions, I would say Alteryx community is definitely a lot of help, or reach out to someone like myself and say, hey, I just got this error. This is a weird error. Can you help me out with that? Absolutely. Absolutely. We can generally get to the end of that. So a good question coming up next. Alteryx is using Python for ML. Will you be doing a seminar on the errors that come out? You know what? I may in the future. That's a good question. I think the reason I'm not 100% on that is the machine learning stuff that is happening. Some of it is happening in Python. There's some of it that's also happening in R. Kind of depends on which one it is. But the issue is that you do have to purchase the new package includes both text mining and the machine learning part. And so there's not that many people that have that yet, but I may consider doing that. I think that's a good idea. I'll probably consider doing that. So that'll probably be later on in the year though. And so the next one is what tool to use if numerical data fields highly correlate with each other. If the correlation is at least, let's say 0.7 to be considered high, then what should be done? Okay, that's a great question because it really is somewhat context specific. If I find something that is the correlation is high, generally I jump up and down, like I'm excited. If I get a correlation of 0.7 and it is an actual thing that's different, like let's say, let's say, I'm going to use this as a weird example because it's just totally not true. But let's suppose that I found out the correlation between IQ and height was 0.7. Man, those are two really different things. And I'm super excited that I finally found a variable that the correlation is that high, let's say 0.7, okay? And again, the way to think about that is you take that value of 0.7, you square it, and that's like that's like a percentage of how much those two variables overlap. So a variable of 0.7 squared, roughly those two variables have overlap of about 49% or 50%, okay, because just 0.7 squared is 0.49, okay? So I would think of that as high, that's about 50% overlap, but again, it also depends on what we're studying. And so again, if I found that in cancer research, I'm probably gonna be suspect. I'm gonna go, I'm not sure I did something right there, but maybe it is a true correlation that you go, holy smokes, we just found the thing that's going to cure cancer. Okay, I wouldn't want to throw it out just because it was high. I wouldn't want to do that extra question added on top of there. So great question, great question. It's just something more to watch out for than anything else. Okay, well, I don't see any more questions. So Rachel, I'll turn it back over to you. And you got these last two slides here.
Awesome. Great presentation, Kyle. And if you guys do have any additional questions, when we send out the recording, we will also include Kyle's email. So feel free to email over any additional questions you may have that we didn't get to today. But last note is to make sure to check out our exciting upcoming webinars that we have both in the data science series, but also our other 3 series, data pipeline, data strategy, and then we actually have an exciting one coming up in visual analytics that Kyle is partnering with one of our Zen masters, and the topic is presenting data science through visualization. So be sure to check that. It's coming out on September 2nd and can be located on our website. But again, the recording will be sent out in the next day or two, and thank you so much for joining us today.
So let me put another plug in for that, just because the Zen master I'm working with, Bridget Cogley, this may be the best webinar we ever produce. So we've been working on it for quite a while. It is, how do you take really, super complicated analytics and make them make sense to someone who has zero understanding of statistics? And Bridget has absolutely blown me away. Like, she and I spent so much time on this, trying to figure this out, of how do we take these things that are really difficult and make them make sense to someone who has no statistical background. And you definitely want to be in this. I think just to watch Bridget do what she does, it's phenomenal. I gave her all the outputs, told her what it meant, and she did this beautiful thing. So huge plug for that.
Yes, definitely. Great point. I put the link in the chat, but I'll also include it in the recording email as well, so you guys can find it easily. Okay, well, thank you so much for your time today, and hope you guys have a great rest of your Wednesday.